This is Anita Wood, and welcome to this topic snippet video that discusses a foundational software development methodology called the Waterfall method. In a previous topic snippet, we looked at why projects fail. After the doom and gloom discussion, we learned that we can help the success of a project if we undertake a true and tried software development methodology. We're going to look closely at one of those methodology. It actually laid the foundation on which many other methodologies are based. The waterfall methodology was once dominant in the software development teams until the present century and the release of the Agile Manifesto in 2001. Most software development projects followed the waterfall methodology. We look at the Agile in a following topic snippet. For example, in 1985, the United States Department of Defense formalized standards every software development company or specialist who contracted work with the DoD must follow, and they were modeled after the waterfall methodology. So if your company could not demonstrate you utilize the waterfall methodology for your development, you could not be rewarded a contract. This demonstration wasn't just making the statement, yeah, we do it. It meant providing evidence of previous projects and all the artifacts that signaled waterfall was used to complete that project. In 2001, the waterfall methodology was broadly considered an outdated approach to the software development, but there are still circumstances under which waterfall is relevant. Why do we really teach this methodology to all programming students? It is because many methodologies we use today are based on it. So, to understand those methodologies, you must understand waterfall. A distinct feature of the waterfall methodology is reflected in its name, waterfall. Water is unable to go back up after it reaches the bottom of a step in the falls. So as programmers, we move through the waterfall method and we can't return to the previous step. You may not move to the next step until everything is completed on your current step. Sometimes this type of process is described as linear, like the flow of the waterfall. It's in one direction. As we saw in the illustration on the previous slide, the waterfall methodology is divided into 7 distinct phases. They include feasibility study, requirements analysis, design, implementation, coding, system testing, deployment, and maintenance. We're going to visit each one of these and briefly define their purpose. The first phase is the feasibility study. The main purpose of this phase is to determine whether it's financially and technically feasible to develop the software. The feasibility study involves understanding the problem. Once there's a general understanding of the problem, it's important to ask if the problem's worth fixing. Remember, sometimes people approach us with a problem, and after closer inspection, it turns out not to be a problem, just a misunderstanding or an incorrect perspective of the situation. So if the problem is worth addressing, then we need to determine which high-level strategy will be used to solve the problem. This is not specific about how the problem is going to be solved, but what strategy we're going to take. The strategy dictates the degree of finances and resources the project will require. The first strategy is, will the problem be resolved with some rework of the current system? This is a less intense one because if there's programs and processes already in place, we're going to respect them and we're just probably going to tweak them. The second strategy is more dramatic. The problem requires a new design, meaning there is nothing currently in place we can use. We are starting from scratch. Though we do have 2 ways to address new design. We can either build it ourselves or purchase something that already commercially is available. This phase cannot be completed without intense user involvement. Obviously, they're the ones with the full understanding of the problem at hand. Trying to accomplish this without direct access to the customer will result in failure, even if everything else is appropriately aligned. One characteristic of the Waterfall methodology is its documentation process. During the entire process, we are creating documentation to record our understanding of the situation at hand. Like now, what the problem is it worth addressing, and what degree of resources we think the solution mandates. At the completion of each phase, there's a deliverable that must be completed. The completion of this deliverable is sometimes called a milestone. Now, deliverables and milestones are outside the scope of this course, but one thing that we do want to know is the deliverable from the previous phase is used as the input for the next phase. So, at the end of the feasibility phase, we start with the user expressing their problem as input, and the output is something called the problem statement. Something that's going to be part of any software methodology is the ability to cancel a project. Here, we're going to call this the go, no-go decision. At various points during the project, we must take a good look at where we are, what we know, and where we think we're going, and make a decision to continue on or stop. We make this decision frequently, and usually after we've added to our understanding of the project, what needs done, and what's going to take to get it done. So, based on the information acquired during the feasibility study, we must decide if we're going to move forward with the project. Well, let's just play along and say we're moving forward so we can discuss the next phase. The next phase is the second phase. It's requirements analysis. We reach this phase with an understanding of the problem, and we have the problem statement document providing us the details. Now we need to determine various requirements that are needed to eliminate the problem to the best of our ability. Nothing's 100%. This is a translation phase, meaning we're taking the user's conversations we recorded in the problem statements, and we must translate them into kind of what we call English-like statements that address the specific processes our program will accomplish to eliminate the problem. We call these statements requirements. If we go back to the IPO chart from the beginning of the semester, we can provide some general details regarding the type of requirements we need to determine. First, what outputs are needed. Then, what processing is necessary to generate that output. And finally, what input is required to allow the processing to occur. As with the feasibility study, the user's involved. Though we're going to spend quite a bit of time without the user while we look for possible solutions. Because the requirements are English-like statements, they are easily understood and evaluated by the user. The user is asked to give the ultimate vote on whether what we present is actually going to help with the problem within their context. Now, remember, the waterfall method is a linear process. We move from one phase to another, and in strict interpretations, we can't go back to the previous phase. We must march forward with our orders. The inability to backtrack puts a lot of pressure on us to get this phase right. During the requirements analysis phase, we must define all the requirements of the final software product. Once the requirements analysis phase is complete, we should have all the information needed to complete the project without any or minimal involvement from the user. Note, after this phase, there's little need to interact with the customer until the product is presented at its unveiling. Not to be overdramatic, but the pressure is on to do this right. We only have one shot. but the importance of this phase is said to be about 20% of the entire project time, and it should be spent in the requirement analysis phase. So, we output the requirement statement document here, and that document is used to make a go, no-go decision as to whether we continue. Let's keep the train going. So, we're a go. Given the requirement statement document, we are now ready to design the software. Notice I said design, not code. The requirements tend to be general and narrative in nature because they need to be understandable by the user, who must vote or sign off on the requirements. What is understandable by the user is far from what's needed for our coders. The design phase is another translation phase. We translate the English-like requirements into programming-specific specifications. Think about the pseudocode we've been writing throughout this class. That's what I mean by programming-specific specifications. Now, the design phase has two subphases. The first is logical and the second is physical. With the logical subphase, we concentrate on writing design specifications in a very general nature. By general, I mean without considering what technology might be involved. We do not write so one particular language or database is favorable. We write so any language or database could be used for the design of the requirements. Now, once the logical specifications are fleshed out, then we add details to that design that are specific to the hardware and software that's going to actually be used to create the code for the solution. Now, the image here shows one method used during the subphases, and it's called data flow diagrams. The boxes in the green are very specific in nature as to what needs to be done, but there's no details provided to how, meaning what language or what database. Now, the tan boxes repeat what needs to be done, but provides additional information about the specific technology required. I just want to show these to you here because many of you will be given data flow diagrams and told to code from them. So notice there's no user involvement here, but like the other phases, we make a go, no-go decision. We go. The fourth phase is where the wheels hit the road and we as programmers start our work. It's when we write and assemble the actual code that turns the specifications detailed in the design phase into a functioning software system. Though you may think this is the longest phase, it's actually the shortest. All the heavy lifting has been done. All we have to do is write the code according to the specification. Now remember, as each designed module is coded, unit testing is conducted. The aim of the unit testing phase is to check whether each module is working properly or not. Once a module is tested, it's combined or aggregated with the other modules. So there's actually another unit testing process that occurs when you add a new module to a project. This unit test actually checks to see how the new module plays with those already present. Notice the go, no-go decisions kind of been removed from our process. If we have just spent time and money coding the project, it's really starting to get too late to shut it down. Not that it doesn't happen, but if you follow the methodology, you should be set up for delivering a functional project on time and in budget. So the go, no-go should not be needed. When the implementation phase has been fully completed, we put on our software testing hats and have to make sure every component of the software system works as intended. These tests use the documentation created at the design phase and run as many tests as possible in an attempt to uncover bugs that need fixed before deployment. This type of testing is called alpha testing. More specifically, this testing is done by us using our systems. It is exhaustive, so many times it does take quite a while. We do not want to send code to the customer to review and have it fail at the get-go. Because we're running on our systems, though, it's difficult to test how reliable the system will be, meaning does it crash when 100 users are logged on? And we cannot test the security of the system. But what we do test is fixed immediately. The next phase has us take the tested product and pre-release it to the customer for some more testing. This is called the beta test. The customers will review the product and see if it meets the requirements set out at the start of the project. This test is performed by real users of the software application in the real environment. It's the final test before shipping the product to the customer. The customer is going to record any issues they find, and depending on the urgency, the fixes may be collected or they may be fixed immediately. The output of this phase is the actual project that's been fully tested and ready to be released to the customer. This phase deployment, the software is installed on the user's system and it goes into production. Now, there's 3 common ways that new software is transitioned onto the user's current system. The first is called direct. What's done is the old system is shut down and the new software is started immediately. So everyone goes home on Friday, the weekend, the new software is installed, everybody comes back on Monday, and voila! This is thought to be really risky because if anything happens, there's nothing to fall back on. Though the data created by the old system is probably around, anything that's created with the new system is not represented in that data. You just have to hope the new software does not mess up while creating the new data. The second type is called phased. It's not as risky as direct. What you do here is you only introduce small parts of the new software and only remove the small portions of the corresponding old software. If something goes wrong, it will most likely not be as catastrophic because you're only taking small pieces. Once that piece is tested and accepted, you go and add the next small piece. Now, the third deployment type is called parallel. It is the least risky, but the most expensive. You keep both systems running, and you have everyone complete their work on both. If anything goes wrong, no problem. The old system is the backup. But everything is done in duplicate, and you are not going to be making too many friends with this one. So really, when all is said and done with deployment, the system is up and running and working. We're not really done yet as far as our involvement with software because there is the maintenance phase, the final phase. This is where the software is in use and the primary job is to keep it available and running smoothly, and that means backing up the system. As the customer uses the software, they're going to discover bugs, errors, or some underwhelming features, and we need to continually support them and make the necessary fixes, release updated software versions to ensure complete customer satisfaction. Like a parent, the child may move out of the house, but you are forever connected to them and are called upon to help them. Like any methodology, the waterfall has its strengths and weaknesses. It didn't establish itself as the dominant software development approach for close to 2 decades by bringing nothing to the table. Interestingly, though, waterfall's strengths and weaknesses are both a product of how simple it is and its linearity. So, let's look at a summary of some of the strengths. All the requirements are known from the beginning. With all the necessary data and requirements up front, estimating timelines, resources, project costs are much easier and more accurate. Now, progress is easier to measure against because it's got clearly defined milestones, since the waterfall employs such a structured approach. Production delays are rare, since the customers do not have a constant input into the process after the first phase is complete. And really, that means we are going to keep some of their changes at bay. The analysis and design stages allow developers to catch errors early on before coding, so they are not making coding mistakes during the implementation phase. While the waterfall method is ideal for most software development teams, those that have upfront, straightforward projects, it does have its drawbacks. Waterfall's linear nature lacks the flexibility to adapt to unexpected obstacles. Delivering projects via waterfall method can take a little longer than an agile method, since it takes a slower chronological approach. Some customers may not be able to really detail all of their needs in the requirement phase, and some may not like the fact that they're not involved, especially in the design and implementation phases. And if a customer is unhappy with the product they receive, reverting to the design phase can cost a lot of time and money. Finally, a delay in one phase of the process delays the rest, causing the deadline to creep where the finish date keeps moving, and it gets delivered a lot later than anticipated. The reality is that in 2022, there are very few software development projects that meet the criteria that play to the waterfall's strengths while avoiding those that expose its weakness. They do exist, which means waterfall methodology is not entirely irrelevant today. A waterfall approach can make sense for smaller projects where the requirements are crystal clear and the required resources are fully available, and there's a tight, imminent release deadline. So that concludes the topic snippet detailing the waterfall software development methodology.